me. Our love was out to get me. That's the way it seemed. Disappointment haunted all my dreams. Then I saw her face. Now I'm a believer. Not a trace of doubt in my mind. I'm in love. I'm a believer. I couldn't leave her if I tried. I thought love was more or less a given thing. It seems the more I gave, the less I got. What's the use in trying? All you get is pain. When I needed sunshine, I got rain. Oh, then I saw her face. Now I'm a believer. Not a trace of doubt in my mind. I'm in love.
This goes here, but it requires this piece. So,
Maybe while he's doing that, I can talk to that system a little bit. It basically has one exit port here, where we put the bigger part of this fiber in. This is here, this is a 1 millimeter fiber. And what this system is doing, it's sending out small modulating light beam. So you can think of a very weak signal that's going on, off, on, off, on, off. And then we can measure the response from the plant in terms of fluorescence to that little modulating beam. What it also does is it can shoot out a saturation flash. It's like a one very strong signal that basically is so high that the plants can't really use it for photosynthesis. So it's so high that you close all the photocenters. And we can explain later what information you can get out of it. So that's the other part. And it also measures directly the fluorescence that's coming back. So usually all the light that's coming out here is from a blue LED, which is kind of in this short wavelength range, not overlapping with the fluorescence signal. So this goes into the chamber, basically via this pointer here into the leaf chamber. And then what's being emitted from the leaf in the longer wave, basically beyond the visible that you see, goes back in here and is being measured.
Okay. So the fan goes in here, and then it's a silicone connection here.
Homer Simpson fingers.
Okay, so then the fiber optic, which remember we hooked up to the QE Pro and this white modulating light, versus this white light LED. The clear fiber goes in here, and there's a little screw to open it up. It's important that this goes in all the way, so that fiber reaches the emission LED, which is about right here.
Let me just quickly show one thing.
Yeah.
That this fiber and all the other fibers that come from the other end are being bundled together here. So you probably can't see it on the video, but here you see one big fiber and then small fibers surrounding it. So this part goes through here, but the other fibers that are basically coming both from the spectrometer as well as the LED are also fed in here, and they are bundled here in parallel with that bigger fiber to actually look out of this metal casing here.
Yeah. So it's 3 200 micron fibers that are going to the spectrometer, and then two 200 micron fibers go to the white LED. And then this can be inserted into this hole. Yeah, so then to insert a leaf, pop this open, unscrew this a bit. And as I mentioned earlier, it's important that this leaf is currently in water and that its stem is a bit longer, and then it's been recut underwater to avoid the embolism.
And if you can off that leaf chamber and it illuminates the leaf, so this is basically the equivalent of a sun. And now he can turn that one off and control it with the system here. Can you turn it off on like this? So what this basically allows us is to give the leaf different amounts of light and see how much photosynthesis it can do with the light.
The key things to then understanding why that spectrum is changing is understanding the environmental conditions inside this chamber, and so we can control that with the gas exchange system. So we can control the humidity inside that chamber by basically pumping in ambient air. So it takes water vapor from the air, and then it either adds some water via the humidifier, or it takes them out via this silicate gel here, which is a dryer, and that'll basically work to control humidity inside the chamber. And then what we can also do is control the amount of CO2 that goes in and out of the chamber. So if we want to just run it on ambient CO2, probably like 420 ppms in this room, we would just have this airflow intake open. But it's important, if you're just running it on ambient air, that you want to run it on pretty still air. So one thing I like to do is just add this hose to it, and then I'll put it in like a 5-gallon bucket, put the top on it, and basically what that does is it creates a really still layer of air, so you're not altering the amount of CO2 or water vapor being taken in through the flow. You can also control the temperature. So you can set the temperature that you want to either set the leaf at. There's a leaf temperature sensor right down here. And you can also control the temperature inside the cuvette if you want. So you can set a cuvette temperature, and then it'll work to regulate that.
Can you in principle also increase the amount of CO2?
Yeah. So you can. So what we did, we just traveled with it, and you can't travel with these CO2 cartridges, so I didn't bring them with. I just ran it on ambient CO2. But if we want to control the CO2 concentration, you can add CO2 with this, and to do that, you just put the CO2 in this, and you'll hear it. If you listen, you'll hear it. So that basically just gave it a pulse of CO2. So now there's a reservoir of CO2 in here, and if we regulate the amount of CO2 reaching the leaf, it will just basically take what it needs from that reservoir.
And these are literally the same cartridges that are being used to put gas in your drinking water.
Okay.
So it's only CO2.
Yeah. And then this is a CO2 absorber basically. So, you know, if you want to lower the amount of CO2 a lot of it will be taken up into this, and you know to replace these when this turns pink. So this stuff will turn pink when it's absorbing a lot of CO2. These dryer gels, you see they're completely orange now, but when they start to take up moisture, they turn clear. And when they turn clear, you want to replace these and then bring them to a drying oven and dry them out.